Now, getting to the ones that were active in supplementing, the phytocannabinoids. So we all know THC, very strongly psychoactive. It's a strong agonist of the CB1 and CB2 receptor, but it first hits the CB1. So its most dominant focus is on the CB1 receptor. Now later when we talk about gene transcription, you'll see that THC has very little effect on gene transcription, meaning expressing your different genes. So phytogenomics is the study of plants regulating how you express genes, and it's a huge part of how herbal medicines work for us. But THC doesn't really do that. THC is more acting on these different receptors. Now CBD is known to be non-psychoactive. Now that it doesn't mean that it doesn't have a neurological effect, because it strongly modulates the receptors themselves. And so in the case of THC, CBD actually modulates which of those receptors the THC hits. So THC dominantly goes after the CB1 receptor when it's alone, and that gets you high. It has a very psychotropic effect. But when you add CB2 in, it nudges the THC over to the CB2 receptor, which gives the THC then more of an immune-enhancing effect, an immunomodulatory effect. You get, and then you also get more of the anti-inflammatory effects of it. So when you're doing cannabis medicine and you are using THC, it's crucial to include CBD in it. But CBD on its own, contrary to a lot of belief that you need to have THC involved, CBD has very strong effects all by itself. And a lot of that, and back to the feeling of changes in mood and changes in well-being in CBD, from taking CBD, is because of the way it stabilizes the glutamate receptor. Takes away glutamate excess and produces a more GABA-toned neurological system, which makes you feel more relaxed. But now another thing that CBD does, and I forgot to put the slide in here for it, is inhibit an enzyme called FAAH, F-A-A-H, fatty acid amylase, or fatty acid amide hydroxylase. And this enzyme breaks down anandamide, and CBD represses it. So when you take CBD, you keep higher tones of anandamide, which give you more of that bliss feeling, which is why you'll take CBD and you'll feel good from it. Some of that effect is from stabilizing neuroinflammation and taking away disruption in your neurological field, and the other side of it is from some weak effect right on the CB1 and CB2, but that augmentation of anandamide. So CBD, as I mentioned, weak agonist for CB1 and CB2. They're now finding that it does bind to CB1 a little bit, but not very much compared to, say, THC. It does modulate anandamide very strongly. It modulates the way that THC hit those different receptors. And it's also very strong anti-inflammatory, which it's very well known for, and the transcriptional modulation I mentioned. So really what I want to talk a lot about now is brain on fire. All right. So in autism, neuroinflammatory action is one of the biggest things that's going on. And as you know, I'm used to treating people with mercury toxicity, mold toxicity, Lyme disease. Neuroinflammation is a massive part of what's going on there. A lot of this is mediated by glutamate excitotoxicity. Glutamate excitotoxicity is making more of a name for it now because of traumatic brain injury. In traumatic brain injury, you have glutamate receptors being hyperactive, and it actually leads to neuron death. So glutamate excitotoxicity actually destroys neurons. So let's look. This is our artist rendition of glutamate excitotoxicity. I think that was from a Brian Eno album. So now looking at the biologist's view of it, in neuroinflammation that's it started from immune reactions, you have what's called glial activation. And so you have activation of the microglia. Often astrocytes are recruited into the brain through a leaky blood-brain barrier. These immune cells aren't supposed to be into the brain, but they get into the brain under stressful circumstances, and they activate the macrophage from, or the glia, the microglia, from a nice microglia to a mean microglia. Now, the mean microglia is going to release reactive oxygen species like peroxynitrite. It says here neurotoxic agents, but what these are inflammatory cytokines, the strongest of which is probably TNF-alpha, and after that, IL-1. So these are supposed to create radical inflammatory reactions, which are pro-oxidant reactions in order to kill infections. But here, they're happening even in the absence of an infection. And so this is creating inflammatory processes in the brain that are not supposed to be present in the brain. And these are generally thought of as chronic processes where you have this chronic low-level inflammation always turning over in the brain. So what are the kind of things that activate this? Well, you've got Lyme and co-infections that often go into the brain, neural Lyme. Neural Lyme is the craziest form of Lyme, so to speak, and because your body may look fine, but you're not reacting well. Your reactions are way off the cuff. Viruses. So here I have human herpes virus 6. That's the most common neurological virus. And there's a little bit of a chicken and the egg thing, because most people have herpes 6 in their nervous system, but it's not being activated. So something is causing it to be activated, and this is possibly recruiting other astrocytes into the brain and augmenting these inflammatory reactions. Beta amyloid plaques can cause this kind of immune activation. Though recently they're seeing that in Alzheimer's, the presence of beta amyloid plaques does not create Alzheimer's symptoms. It's inflammation underneath or within the context of the amyloid plaques that causes the symptoms. And then they're finding that there are background infections behind all of that. So there's a number of other infectious sources that can get into the brain and cause this inflammation, but also some of the environmental toxins, like mold toxins, can cause not just direct toxicity to the brain, but can cause immune reactions. That's one of the stranger aspects of mold toxins, is that they activate the immune system as well as being direct toxins. So this is a really good I apologize. These projectors are a little blurry, but this is a picture of self-propagating neurotoxicity, where you've got inflammatory triggers that are more immune-based triggers, but they can. Now you'll notice over here, lipopolysaccharides, which are parts of bacteria that you get from leaky gut or that you get from chronic infections in your jaw or sinuses. They can be activating the immune system. A number of these different toxins, you have paraquat, rotenone, those can be activating the immune system and causing the glia to release all these pro-inflammatory cytokines, which are then causing damage to the neurons. And the neurons are then turning around and releasing more immune signaling compounds that are amplifying the inflammatory release of the microglia. So this wheel is turning like this. And the wheel can be turned or initiated from the inflammatory trigger that's more immune-based, any toxin that amplifies the NMDA receptor. That's the glutamate receptor. Many toxins, mechanism of action is through stimulating the glutamate receptor. So which ones do this? Mercury, very well known for doing that. Oh, look, everybody's favorite, glyphosate. And guess what we're going to show later that blocks glyphosate toxicity. Mold toxins do this. Lyme toxins do this. EMF stress stimulates the glutamate receptor, and if you hang out at enough of these conferences, you'll know that for sure. Anybody dealing with a little bit of neurological stress here? Product toxins can do this. I mean, how many times do you get into the situation where yourself or the child is having bad neurological symptoms, and you notice they're super gassy at the same time? You give them something to control dysbiosis, some antimicrobials, artemisinin, biocidin, and all of a sudden, this calms down and the brain clears up. They tend to go together. As the GI inflammation goes up, the neuroinflammation goes up. They tag along together. And is that because of the toxins coming through the GI tract into the brain? And, with the GI inflammation comes the leaky gut, and with that comes the endotoxin. Then that inflammatory trigger opens up the blood-brain barrier, and the whole thing goes into this cycle together.